Today we're going to be talking about two specific types of triangles, isosceles and equilateral triangles. Let's start with isosceles triangles. Now remember that an isosceles triangle is a triangle that has at least two congruent sides. Now those two congruent sides we call legs, and then the angle that's formed by the legs is what we call the vertex angle. The third side, that's not one of the congruent sides, is what we call the base. And then the two angles that are adjacent to the base are what we call the base angles. So just so you have a visual of everything that we're talking about here, you see the two legs that are congruent, you see the vertex angle up on top, the third side is the one at the bottom, the base, and then the two angles that are adjacent to the base are the base angles. Now the first theorem we're going to talk about is the base angles theorem. So if two sides of a triangle are congruent, or in other words, if you have an isosceles triangle, then the angles opposite those two sides are congruent. So here's a picture. We have AB and AC congruent to each other. If you know that's true, then you also know that angle B is congruent to angle C. Now the converse of that theorem is also true. Remember that the converse is when you switch the if and then parts of the statement, and it's not always going to be true. In this case, it is. So this says if two angles of a triangle are congruent, then the sides opposite them are congruent. So in this picture here, if you know that angle B is congruent to angle C, then you know that AB is congruent to AC. Let's take a look at this first example. So you have a diagram on the right there, and you are to complete the statement. If HG is congruent to HK, then angle what is congruent to angle what? Okay, so it looks like we're looking at the triangle that's on the left there. So if HG is congruent to HK, then we know that the base angles are going to be congruent. That would be angle G and angle K. Now if you were to say angle K here, it's not clear which angle you're referring to. So we're going to go ahead and use three letters for both. So we'll say angle HGK is congruent to angle HKG. All right, number two, if angle KHJ is congruent to angle KJH, then which two sides have to be congruent? So looking here, it looks like KHJ, we're looking at the triangle on the right and looking at the angle up on top. That's KHJ. And then KJH, that looks like the angle that is on the far right. Okay, so if those two angles are congruent to one another, then which two sides must be congruent? Then the sides opposite them, which would be KH and KJ, are congruent to each other. And so that's number two. All right, a couple of corollaries. Remember that corollaries are really just results from theorems that are perhaps more specific. So more specific than an isosceles triangle is an equilateral triangle. Now an equilateral triangle is a type of isosceles triangle where the third side is also congruent to the other two sides. So as a corollary to the base angles theorem, we would say that if a triangle is equilateral, then it is equiangular. And a corollary to the converse would be that if a triangle is equiangular, then it is equilateral. So the converse will also be true for equilateral triangles as well. So equilateral and equiangular, they mean different things, but if a triangle is equilateral, that means it's equiangular. If it's equiangular, it's equilateral. All right, take a look at example 2. Find the measures of angle P, angle Q, and angle R. Now, we see here in the diagram that all three sides are marked as congruent. That means we have an equilateral triangle. Now, since we have an equilateral triangle, we know based on the corollary to the base angles theorem that this triangle must also be equiangular, meaning that all the angles must also be equal. But what are they equal to? We don't seem to have any other information. Well, we're going to have to apply what we know about triangles and interior angles. Remember that interior angles of a triangle will sum to 180 degrees by the triangle sum theorem. Well, in that case, if the measure of angle P, Q, and R are all equal to each other, then we can simply say that we have 3 times the measure of one of those angles, say angle P, is equal to 180, which must mean the measure of angle P is 60. So if all of those angles are 60 degrees, then they are all equal to each other, and the interior angles will add up to 180 degrees. All right, let's look at example 3. Find the values of x and y in the diagram. So looking at the diagram here, it looks like we have an equiangular triangle, KLN, and we also have an isosceles triangle here, LMN. Now, we're going to use that information to help us find x and y. Let's start with y. So since we know that triangle KLN is equiangular, that means it must also be equilateral. That means that all the sides have to be equal. So if KL is equal to 4, that means that KN must also equal 4. So y has to equal 4. Now to find x. Well, if we know that all those sides are equal in that first triangle that we just worked with, that must mean that LN must also equal 4. Now that you know ln is equal to 4, you can also apply the fact that we have an isosceles triangle, which means that those two sides, LM and LN, must be congruent to each other. So that means LM must also equal 4. So x plus 1 has to equal 4. Solving that, we get x is equal to 3. So the values of x and y in the diagram, x is equal to 3 and y is equal to 4. All right, we have one last example. In the lifeguard tower, PS is congruent to QR and angle QPS is congruent to angle PQR. A. What congruence postulate can you use to prove that triangle QPS is congruent to triangle PQR? Then explain why triangle PQT is isosceles and show that triangle PTS is congruent to triangle QTR. Okay, so in the diagram here, I know it's a little bit harder to see, but in yellow there, the letters are there, P, Q, R, and S. And then we have some angle measures labeled 1, 2, 3, and 4. Now, I think that it might be helpful because these triangles overlap each other. We're trying to look at two triangles here, QPS and PQR, and those two triangles overlap. So I think the easiest thing to do is to actually redraw them so that they don't overlap. Okay, so we've drawn and labeled triangle QPS and PQR so that they don't overlap. Now, what congruence postulate can you use to prove that triangle QPS is congruent to triangle PQR? Well, if you're told that PS is congruent to QR, so we've marked that in the diagram, we're also told that angle QPS is congruent to angle PQR, so we have that marked as well. And then because they share side PQ, we know those are equal to each other as well. So we actually have two sides and an included angle that are congruent to each other. So PQ congruent to QP, PS is congruent to QR, angle QPS congruent to angle PQR. So by side angle side, we can say that triangle QPS is congruent to triangle PQR. Okay, part B. Explain why triangle PQT is isosceles. How do you know that triangle PQT is isosceles? Now you might want to go back to the original diagram. Well, if we're trying to find how triangle PQT is isosceles, we need to be able to show that there are two sides that are equal to each other. Well, from the side angle side congruence postulate, we were able to show that those two triangles were equal to each other. Since corresponding parts of congruent triangles are congruent, we can say that angle 1 and angle 2 must be congruent to each other. And going back to our converse of the base angles theorem, we can say that PT is congruent to QT, which means that triangle PQT is isosceles. All right, and the last part, show that triangle PTS is congruent to triangle QTR. Okay, for this, PTS and QTR, we know that angle 3 and angle 4 are congruent to each other. We know that angle PTS is congruent to angle QTR because they are vertical angles. And we know that PS is congruent to QR. So, because we know all those pieces of information, we have two angles and a non-included side. And so by the angle-angle side congruence theorem, we can say that triangle PTS is congruent to triangle QTR.